Welcome to the first installment in this series of videos aimed towards professional creatives who would like to implement generative AI into their workflows. Throughout these lessons, I will try to guide you through setting up workflows that can be considered production ready. Since we, as professionals, need to deliver results consistently to clients, working with generative AI can be quite frustrating at times. In this series, we'll see how the randomness of this tool can be tamed and how Stable Diffusion and its various third-party plugins can now help with that. In this lesson, I will guide you through the process of setting up your own Stable Diffusion workspace and running your first generations. But first, what is Stable Diffusion? Well, at its core, it's a tool that can be used to generate new images from a user input and parameters. It is based on a latent diffusion model, and diffusion models work by gradually transforming random noise into a structured output. Since the process is quote-unquote non-deterministic by nature, we need a way to tame the randomness to work in production environments. This is something we'll need to focus on later, but it's one of the reasons why we're using Stable Diffusion and not other generative AIs such as Midjourney or DALL-E. As an image generation model, it's capable of generating images from text, images, or both. It's also open source, which means its code can be accessed and reviewed, and it's customizable, both in terms of the end user, that's you, or third parties, who develop add-ons and plugins for the ecosystem. Now, why should we, as professional creatives, use Stable Diffusion? Well, first thing, it's free. Most of the other generative AI tools aren't, and a lot of them are just basically reskins of a Stable Diffusion instance specialized in one thing. So why pay for something you can run for free, locally, and fine-tune to your own needs? It's also powerful. Its speed is only bound by the workflows you set up and the hardware you have, so you don't need to rely on third-party servers to keep up your production. It also elevates and speeds up your existing workflows. It can automate parts of your routines, such as brainstorming, tests, everything that involves lateral thinking, and more. And also, it's new. Clients, right now, are willing to pay a premium for AI-generated content. This might probably change in the future, but it's one more tool at your disposal, and not a lot of people know how to use it properly. Now, counterpoints. Why should we not use it? We might have ethical concerns. I'm not going to delve too much into this during the first lesson, but the way generative AI works is by training on large datasets. The way these datasets are formed is highly debated right now, and there is a divide between those who think that the training data harvesting process falls under fair use and those who oppose this view. We might also have legal concerns, both in terms of datasets collections or commercial uses or copyright laws. This highly depends on the country you or your clients reside in, so I cannot give you a catch-all answer to that question. We might also like our existing workflows, and that's absolutely fine. What I'm presenting is simply a new tool and some ways to use it, but there's no need to stray from an existing workflow if it already works for you. Now, what are we going to need to work with Stable Diffusion? Well, first of all, we need a very basic understanding of coding. Don't get too scared about this, we're not going to see a lot of it, and depending on your workflows and needs, you might just need to run code once or twice. But knowing a bit of Python and how to work your way around the command line interface does help a lot. We also need some hardware. A GPU or graphics card is what will handle the computations needed in order to generate these images. Keep in mind that the more powerful the GPU is, the faster the generations are going to be. And you can do more stuff with it, like training, fine-tuning, etc. In case you don't have a GPU or are running a very old one, you could also run Stable Diffusion on a powerful enough CPU, but that really depends on what you're working with. Not every GPU or CPU is created equal, and if your hardware is not suited for running Stable Diffusion locally, there's still some cloud-based solutions for you. We will also be using ComfyUI. ComfyUI is one of the three main user interfaces for Stable Diffusion right now, the other two being Automatic 1111 and Focus. We're going to be using ComfyUI because its node-based approach gives us a higher degree of customization. It is harder at first, at least compared to other UIs, but I believe that it can be easily taught, at least by breaking it down into tiny bits to help understand it better. We are also going to need one or more models. Models are what we use to interpret the noise and solve it into an image that can be understood by a human. Stability AI, the publishers of Stable Diffusion, offer their own models, such as Stable Diffusion 1.5, 2.x, or SDXL, but you can find custom models on other platforms. The former are usually referred to as base models, while the latter are fine-tuned models. On the other hand, we're not going to be needing advanced coding experience, powerful and costly hardware, and subscription. So don't be intimidated by this introduction, and let's get into it. So, in order to install and run Stable Diffusion on your hardware, first of all, we need to install Python. Simply go to python.org/download, grab the 3.11 release, and run the installer. Now, I'm not using the latest release because at the point of recording this, I don't want to run into unforeseen errors that are due to version mismatches, but feel free to experiment with a newer release if you really want to. If you're on Windows, remember to check the Add to Path option. You can find the link to download the release I'm using in the description box below, where I leave also some links to videos on how to install it on Windows, macOS, and Linux. Once this is done, we're going to be downloading ComfyUI. Once again, you can find the link in the description below. This is a page on GitHub. You'll need to familiarize with it, at least to some extent, as it's where most of the custom nodes are released and maintained. On top of the page, you can see that this is a project by a dev, Comfy Anonymous, and the project name is ComfyUI. In the middle of the page, you'll see what's inside the release, if you wish to inspect it. What we're looking for, though, is a bit further down, in the README section. Most of the code on GitHub will have more or less detailed README files with infos on what the project is, how to install it, and run it, and more. Here, we can look at a list of features, that is, why we're using ComfyUI instead of other UIs, and a bit further down still, we can find the installing instructions. I will focus on Windows since this is my platform, but you will be able to find instructions for Linux and macOS as well. For the sake of brevity, I will proceed to show you how to install ComfyUI on one hardware configuration only. For this, you need Windows as an operating system and an NVIDIA GPU. If you have any other configuration, you can follow the installation steps on the GitHub page for your own hardware setup, and you can find more resources in the description below. If, and only if, we're running on Windows and have an NVIDIA GPU, we're going to download the ComfyUI portable version. This is a release with mostly everything we need already inside of it. Click on the link and download the zip file to a location of your choosing. Once the download is finished, you can unzip the contents. If you're running another OS or other hardware, please check the links in the description below. Once that's done, if you're among those who are operating on Windows and running an NVIDIA GPU, ComfyUI is successfully installed. Otherwise, I trust you followed the installation processes I provided in the description. Before generating, we need two more things. One is necessary, while the other is an immensely useful quality of life improvement over the base ComfyUI. We'll start with the latter. Go to the GitHub page for ComfyUI Manager. You can find the link in the description below. Go to the installation section of the README and follow the instruction. That is to say, inside the ComfyUI folder, we will navigate to and open the folder named Custom Nodes. We open the terminal by right-clicking inside the folder and selecting Open in Terminal, and we'll copy the command line git clone URL of the repository and paste into the terminal, just like we did before, and then press Enter. And that's it, the manager is installed. Now we will need some models. In order to get a model, we have two choices. We can go to Hugging Face, which is a website where developers release models, and grab the base Stable Diffusion models, such as Stable Diffusion 1.5 or SDXL. You can find the links in the description below. Or we can go to civit.ai, a website where users and developers release the fine-tuned models, and download a model of our liking. I will leave some links to some of my favorite fine-tuned models in the description below. Now, one thing that I don't feel like it's mentioned enough is that civit.ai is a great place for finding fine-tuned models, but there's also a lot of not safe for work stuff on there. So if you don't want to find yourself browsing not safe for work stuff, you can just disable those kind of content by filtering out the not safe for work stuff. For this first walkthrough, I will download a model from civit.ai. Its name is Epic Realism. In order to do so, I'll go to the civit.ai page for the model, select the latest release and click the download button. You can find the link in the description below. When downloading models, keep in mind that you should always try to download the .savetensor models, since they're much safer files than .ckpt models, which can contain malicious code. Download the model and save it in your ComfyUI folder under Models, Checkpoints. Now we need a VAE. VAEs are models that are needed to decode images. We will download the base models now. Some models work best with certain VAEs, others don't need VAEs. Since we want to make sure that we've got everything that's needed anyway, follow the link in the description for the VAE and download it, placing it in your ComfyUI folder under Models, VAE. So at this point, your directory for ComfyUI should look something like this. Under Models, Checkpoints, you should find your Epic Realism model, and under VAEs, you should find your VAE. Now that everything's ready, we can launch ComfyUI. If you're using, like I'm doing, the ComfyUI portable version, go to your ComfyUI folder, and if you're using a GPU, locate the file named run NVIDIA GPU.bat. Otherwise, locate the file named run CPU.bat. Double click on it, and since it's the first time we're launching it, it's going to take some time to run. If you're running a non-portable version, you need to open your terminal inside the ComfyUI folder and type python space main.py and hit enter. Regardless of your startup method, when it's done preparing everything, it will open up a window in your web browser where you'll see a blank dark canvas. This is your current ComfyUI instance. Inside of this space, we will need to compile a sequence of nodes to guide the generation process from start to finish. In order to do so, let's start with the first thing we need. We need a latent image, so we'll double-click inside the canvas and the search menu will pop up. We will just type latent image and we will be presented with more or less choices depending on what we're looking for. Since we're just starting out and we need an empty latent image, we will select empty latent image. This will create a new node in the workspace. This is the node that dictates the resolution of the image we will be working with, as well as how many images will be generated. For now, let's keep it at 512 by 512 pixels of resolution and at batch size 1, which means only one image will be generated every time we request a new image. But, well, what is a latent image? Think of it as a blank canvas upon which all the parts of your prompting, models, VAEs, samplers all work together to generate an image. It's basically your camera sensor, your blank canvas if you're a painter, it's your piece of paper if you're an illustrator. It's basically the fundamental thing that we're working on. So that's the first thing we're going to place inside the workspace. Now that we have a latent image, we will need some inputs to let Stable Diffusion know what we want to generate. Well, first of all, we need to choose a model. In order to do so, we double-click again in the work area and search for Load Checkpoint. A checkpoint is the model we just downloaded, and we're loading it in the workflow so that the program knows what model we want to be in charge of the generations. Now you can see that this new node has 3 outputs and 1 folding window. Inside the folding window, we can select our model. The 3 outputs are model, clip, and VAE. Let's start with model. The model output is in charge of transferring the model throughout the process, so that the program can understand that we want to use this model throughout the generation. The clip output is in charge of transferring the modifying elements, such as text prompts, throughout the process, so that the program knows how we want to affect the generation process. The VAE output is there in case the model has a VAE inside of it already, and we don't need another one for the process to continue. So let's start with the clip output. If you click and drag from the clip output and then release your mouse button, you'll see that a new window will pop up. one with suggestions for nodes that can interact with the selected output, and that is true for every output. Here we can find clip text encode. We will click on it and a new node will pop up in the workspace. This is the node where we can input positive and negative prompts. Positive prompts are what we would like to see in the final image, while negative prompts are the opposite, what we don't want to see in the final image. Depending on your model of choice, it might be best to give detailed description of what we would like to see, or you should just focus on keywords. Since we now have only one clip text encode node, we will duplicate the clip text encode node by selecting it and going Ctrl+C and Ctrl+V. Then we will link the second clip text encode to the clip output from the load checkpoint node. This will give us a positive prompt and a negative prompt node. As you can see, more than one resulting node can be linked to a single output. But where do all these inputs go? Well, to solve these inputs, we will need a solver node. This node is called KSampler. Double-click on the workspace and search for it, or drag and drop from the model output on your load checkpoint node and find it under the Suggested Nodes tab. Inside the KSampler node, we can see how all these outputs we have in all the other nodes have a corresponding input. The model output goes to the model input. The positive conditioning output goes to the positive input, same as the negative one, and the latent output goes to the latent image input. Now we hook all those outputs and inputs up, and we will be almost there. The KSampler node has a bunch of variables in it. Going from top to bottom, we have seed, which can either be a random number that generates a random image for each generation we request, or fixed if we want the same seed every time, and other options. The seed is now 0 since we haven't requested the generation yet. And in order to choose between random and fixed, we can look at the control after generate field and select, for example, randomize. This will generate a random seed every time we request a new generation, thus creating a new image every time we request one if everything else stays the same. On the other hand, if we choose fixed, a new image will be always the same as the previous one if everything else stays the same. Under these, we will find steps. This is the number of times the generation needs to iterate before coming to conclusion. Each model has a suggested number of steps as well as other settings. For these ones, we'll keep it at 20. The more powerful your hardware, the faster the iterations will go, and the more steps you can go through in the same amount of time as a less powerful hardware. CFG is a hard one to explain, but think of it as how close the final result must be to the prompts and inputs you're providing, or how far and free from conditioning the generation can be. A lower value of CFG can result in a generation that is farther from the user inputs, while a higher value will be closer. However, choosing too low or too high a value relative to what the model can handle will result in artifacts. Sampler name lets us pick the quote-unquote method of how the image will be generated. Some samplers are better suited for realistic images, while others are more suited for stylized images. Some are faster but they sacrifice quality, some are slower but are more detailed. All in all, a sampler is an algorithm, and it is responsible for the actual generation of the image. For this example, we will pick DPM2, which is a good sampler if we want to go for photorealistic results. The scheduler is another algorithm that is responsible for the sampler's sequencing and parameters, or how it adds and removes noise from the image while generating it. As with the sampler, some have better uses in certain fields than others, and they have strengths and trade-offs. Since we're going for photorealistic results, we will select Keras. The last parameter in the KSampler node is denoise, which is how much we want to quote-unquote stray from the original latent image. Since now we're using an empty latent image and we're generating text to image, this parameter is mostly useless. We will later see how it affects image-to-image generation processes, but for now, let's leave it at 1. Now, the KSampler node has only one output, and that is latent. But we don't want a latent, we want an image. In order to do that, we'll need to decode the resulting latent. Drag and drop from the latent output and select VAE decode. If you remember from before, VAEs are used to decode latents into images. Now this node has only two inputs, samples, which will be linked to the latent output from the K-sampler, and VAE. Now we don't have a VAE node yet, but if you remember from before, the VAE is a model. So what we're looking for is a load VAE node. Double click in the empty space and look for load VAE. Here we can select the VAE of choice and hook it up to the VAE input in the VAE decode node. Finally, from the VAE decode node, we can drag and drop and select preview image. This will create the final node we need. As you can see, this node has no further output. It's the end of the chain. This is where the generated image will be displayed. But wait, we need some actual prompts. We're doing text-to-image generation, but the text fields are still empty. Let's go back to the clip text and code nodes then, and add a prompt to the positive and negative prompt fields. For positive, I will write fashion photography, film photography of a young woman wearing haute couture clothing. And for negative, I will type some random keywords I don't want to have in the final results, such as horror, watermark, illustration, 3D, render, anime. Now we have everything set up, and we can go to the menu bar on the right side of the window, where we can hit the Q prompt button. If we did everything right, the generation process will start, and after a while we will be able to see the generated image in the preview image node. If we want to save it, we can right-click on it and save it. If we want to automate the saving process, we can add a save image node to the VAE decode image output. We can also have both a save image and preview image node at the same time. I mean, having these two nodes at the end of the chain will not do much, since the save image node will display the image regardless, but you can see how you can have two different nodes appended to the same output. And that's it! That's your first text-to-image generation. Congrats! But what if you wanted to start from an already existing image, thus generating an image through a process called image-to-image? Well, in order to do so, we have multiple ways to do it, but for this lesson, we will start with the most straightforward one. Now let's think about it. Since an image is generated from a latent, we can influence the end result by encoding an image into a latent. To do this, we will search for the VAE encode node. This node requires two inputs, a VAE, which can be the same that we are already using, and an image. We will go ahead and link the VAE output to the VAE input, and then double-click and search for the load image node. This node can be hooked directly to the VAE encode node, but this will result in a latent with the same pixel sizes as the loaded image. If the loaded image is much bigger than 512 by 512 pixels, for example, the generation process might take ages or might not run at all. So, we need to resize the loaded image first. We can search for a resize node by typing resize and finding a resize node that fits our needs. But what's this? No resize node is coming up in the search window. Well, this is why we installed ComfyUI Manager. So, go to the menu bar on the right side of the window and click on Manager. A new window will pop up with a lot of infos. For now, we just want to install a node we don't have, so we'll click on Install Custom Nodes. Once again, a new menu will pop up. In the search bar, we simply search for resize and grab the node we want to install. In our case, that's various ComfyUI nodes by type by James Walker 55. How do we know that's the node we're looking for? Well, if you're not sure that a node fits your needs, you can just click on the node's name and the GitHub page for the node will pop up in your browser, where you can check if the node is right for you. After we click on install, we need to restart ComfyUI for the changes to take place, so we'll click on the restart button. The workspace will lose connection, and after a while the node will be installed and the connection will resume. Now we can search for the resize node in our workspace and tada, there it is. We will dial in the desired sizes, let's say 512 by 512, and hook up the load image node to the image resize node and the image resize node to the VAE encode node. The VAE encode node will now replace the empty latent image node, since this is the new latent we want to be working with. Hook up the VAE encoder node to the K-sampler under the latent image input, and the node chain is once again complete. If we launch a generation though, we will see that the resulting image is quite different from the one that we loaded. That's because we asked for a resulting image that is processed through a K-sampler with a denoising parameter of 1. Denoising goes from 0 to 1, where 0 is basically nothing changes from the starting image, and 1 is the starting image is just a rough suggestion. In order to generate an image that is close to the starting image, we want to experiment with a different denoising value, so let's try with 0.5. We hit Q prompt, and as you can see, the resulting image is now much closer to the starting image. But if, on the other hand, we want a resulting image that is still very close to the starting image but has some significant details that are different from it, we can just put a denoising value of, let's say, 0.7 and see that the resulting image will be still close to the starting image but with some minor details and some significant details that differ from it. Now you can change values, settings, and prompts and generate new images. But for now, this concludes this lesson for Stable Diffusion for professional creatives. If you like this lesson, please consider liking this video and subscribing to the channel, as we're just starting out this journey and it will help us greatly. Please comment if you have any suggestion on this video or if you have any topics you might want to see in the future. I am Andrea Baioni. You can find me on Instagram at risunobushi and on my website andreabaioni.com. Then go on, experiment with what you learned today, and until next time.